Alright guys, so when we last left, we got our GraphQL server template up and working. We had a schema and the resolvers, so that's great, but what we really want to do is make those not be placeholders, but more of what we have in our actual file. So what we normally do in GraphQL is we have a file specifically for just the schema and another file for the resolvers. In fact, it's pretty common that you have multiple schema and resolver files and you actually combine them into one big composite schema and resolver file. So as an example of that, let's look at this other project here, and you can see, unlike in our little example where we had the resolver just returning a static and the schema being hard-coded, just some hard-coded data. In this one, what we have is when we build the server, we actually pass in the type defs and resolvers, and those are defined, each of them, in a file. So we have one file for resolvers and one file for the type defs. And if we look at those files, you'll see the schema will be quite detailed with all the objects in it. And the resolver will also have a function that returns that particular data member of each object that we defined. So that's basically what we want to do with the sheep project as well. So let's go ahead and start on that. First thing, make those files. So we'll have one file for the schema, and we'll have one file for the resolvers. Okay, so now in these files here, they both have a special format. The schema file has to be in the markup language that we use for creating GraphQL schemas, which we just call it GraphQL language here. And we'll just copy this in to our other project because we basically always use the exact same type thing here. And you'll see there's this little backquote here. This is basically saying this is going to quote it out. And so everything in here will be this type def. And when we talk about GraphQL, one thing that we define are the queries, which are the different queries you can do on the system and what data each of those queries returns, and also the arguments, if any, that query takes. And then we have the mutations. The mutation changes the data. So query just returns data. Mutations are functions that change the data. And then for each of these objects that you define as part of the query, you have to define it as a type. And in GraphQL, they distinguish between output types, which are just called types, and input types, which are parameters that you can pass to the server. So with that in mind, usually what we do first is define the queries that we can do. In ours, it's actually pretty simple, because what we really have is we want to have a query to get the levels. And so that could be a query that just returns an array of the type of object that we want to return, in this case a level object. So I could say I could have a query called level, and it just returns an array of level objects. And of course what we have to do then is, when we define that, we also have to say what these objects are. And so in this case, we have to go down and create a type that has all of the properties of the level in it. So, and we have to have the right notation for this, so let's just put this surrounded by brackets, which is what GraphQL likes. And then you'll see here that this is not the level is not defined here. So we can say type level, and we know that the level had a name, and we know that it had a description. So once we have that defined, then you'll see that the level is now no longer in red. We still have the query in red, but really the only reason the query is in red is because we haven't finished that definition yet. So let's go and do that. All right. So let's look at the other members that we need to put here for our level, because we know it wasn't just a name and description. Let's go ahead and open up that other file that we had defined within Unity. So if I go here to my drive and try to find this file, go into my assets, and it should have my scripts, and then I have my level file. And I'm just going to move that over here so we can see them both at the same time. And here is my level. So I have the ID, which we'll just make an ID, which is a standard GraphQL type. And we know, see that it has sheep, which is an array of type sheep. And we have the size of the level. So we have width, so float. There we go. Height, float. We have this single object here, which we're going to define. Basically the location of the exit. We already did name and description. We have allowed time, which looks like an integer. And now we start having all the obstacles. We're going to keep these things the same name that I used here so that we can read in that JSON document without any problems when we actually get to that point. All right, and as you might guess, once we have these defined, we're also going to have to define all those missing objects here. So we can start at the bottom or start at the top, either one, And since we have our classes over here, we can use these to kind of help inform us. So let's start with the sheep object. It's going to have very simple. And we do a single object. So as you may imagine, the difference between a sheep and just a normal object that's an obstacle is really that an obstacle can be rotated. So I have an extra parameter there. Fence object, slightly more complicated, because a fence goes from one point to another. So here we're going to have start x as a float and start z as a float and end x and end z as floats. And again, as you kind of fill these things out, you can see we're removing errors from up above in the level definition. Next one, puddle objects. Interesting, it appears that we actually have a little bug here, or a potential bug. I put these as single objects, but they are in fact puddle objects. So with that, let's go back and define what those puddle objects are. And the reason the puddle object is like that is because in the game, a puddle is represented just as a oval. So it'll have an x location and a z location, but it will also have a width and height associated with it. And that will be the width and height out from that center location. And it also has a rotation angle. Let's see, the dog run. Dogs in the game run between 2 points. So they're going to need to have a start x and a start z and an end x and an end z. Dogs also have a speed that they run at, which is also a float. So we still have to do the rabbit hole and the star. So start with what a hole looks like. Hole just has a location. You can't change the size of them. In the game, they're all the same size. And then we have the type, which is the actual rabbit hole, which has 2 holes associated with it. It has the entry hole, and it has an exit hole. So when I go into a rabbit hole, I go in one side and I come out the other. The final one we have is the star. Star, if you remember, we hit those when we get them, we get a bonus of time. So, but otherwise, all the stars look the same. So for stars, we again have the x loc and the z loc, but we also need to know what the bonus is. It's how many seconds get added to the clock when I collect that star. So now we are looking good. All right. And the next thing that we would want to do here is in GraphQL, you'll see if I go back to my other schema from the other program, you can see that we have these exclamation points periodically. What these mean is that this parameter is mandatory. And so if I have something like, hey, I'm going to query to get the sectors, this exclamation point means this will always return an array. The array might be empty, but it will always return an array. Whereas sector could be nil, so this could be an empty array. Likewise, see if I can find another example here with it in a slightly different way. So if I look here, I have the ship type. For the name, we have a string, and the string does not have an exclamation point after it, so this could be null. It's possible for it to not have a string, but it has to have a mass, it has to have fuel storage, it has to have physical and energy attack, and so on. So we can use this to kind of help shape the data and describe how it's supposed to work. So hopefully that will work well. Let's go back to our system and then see if there's anything that we have to do there. So we know that the level is always going to have an ID. It doesn't have to have a name or description. It has to have at least one sheep. So what we'll do is we'll put an exclamation point here, meaning this will never be an empty array, and it will always return a value. It's going to always have to have a width and a height. It always has to have an exit and allowed time. It doesn't have to have fences, but we want to return, and we don't even have to return an array there because we can just test for null. So these things could be totally missing. All these other ones are basically optional. If we do have a sheep, it has to have its x and y, x and z values. Same with a fence, all its values are required. A puddle, it has to have all of its values. The dog run has to have both a start and end. The hole needs both of its values. And of course, the star needs all of its. So now we've made a very simple schema here, and we should be able to go ahead and use this in our system. So now if we save this, we should be able to see if that's working here. And again, we can just try it off of the server, and oh, actually we can't do that quite yet. Let's cancel that. Forgot one little thing there. We are not actually using this schema yet. So let's get rid of these things here, and instead we're going to import that. Just like we did here, where we just required this as a file and then it brought it in, we're going to do the same thing. So we can actually just copy this. Now we should have this new file here. So now let's give that a try. Cannot read property sum. Yeah, something seems weird. schema looks okay, but we have this query thing here still.
You're about to be scrumptious.
Hang on a sec. All right, sorry about that. A little bit of excitement. But let's close this one here, and let's see, save that one out. We got the type defs resolvers set. And we will go in here. Looks good to me. Don't see any problem here. Let's see what's up with our node. All right, polysolver, obviously some kind of type definitions is off, so it's definitely missing something. Oh, we didn't export this from our thing, so it's actually not finding it. If we look at our schema file here, we define the type def, but of course this file is being required, and so we actually need to export that from the module. Won't find it if it can't do that. So let's go try this one. And now we can see our server is ready. We'll double click on it like we did before. And now when we look at our schema, you can see that our whole schema is defined here. And when we're in our next step, we will take this schema and we will write resolvers in it that will return data, and then we can start showing how we can pull that data off in our app. So thanks, and tune in next time.